Hello all, welcome to my channel. In this video, we'll be seeing everything you need to know about a voltage divider. We'll first talk about how the voltage division works, and then finally we'll solve some problems from simple to complex to understand their application in a practical circuit. So let's get started. Voltage divider is one of the most fundamental concept in electrical and electronics engineering. It is a very simple and yet a powerful tool to solve complex networks. So to understand voltage divider, all you need is a voltage source V and two resistors R1 and R2. So let the voltage across R1 be called V1 and voltage across R2 be called V2. Therefore, the total applied voltage V is nothing but sum of the voltage across R1 plus voltage across R2. And the voltage divider name comes from the same understanding. The total voltage applied V is nothing but the sum of voltage across the resistors connected in series to V, in this case R1 and R2. Our motto is to find V1 and V2. To find that, let us assume the current in the network is I, and therefore V1 is nothing but current through the resistors R1, that is I, into the resistance. And similarly, V2 is the current flowing through the resistance R2 into R2. So to find out V1 and V2, the only unknown thing is I. And to find I, all you have to do is, if you have a circuit like this V with the resistance R, the current flowing in the network I is nothing but V by R. Therefore, for the given network, the R here is replaced with two series resistance R1 and R2. Therefore, they can be combined into one effective resistance R given by R1 plus R2, since they are in series. Therefore, the current I flowing through the network is nothing but voltage V divided by the total resistance, that is R1 plus R2. Now we know I, we can find V1 and V2. So V1 is nothing but I into R1, therefore it is nothing but V into R1 divided by R1 plus R2. Similarly, V2 is I into R2, therefore it will become V into R2 divided by R1 plus R2. And that is all there is to know about a voltage divider. To summarize it shortly, to solve a voltage divider network, all you need to know is the current flowing through each resistance, and then you multiply the current with the respective resistances, and you'll find the voltage across those resistances. So let's solve some examples. Example 1. you have a voltage source V applied to two equal resistances in series. And we need to find V1 and V2. So the first rule is to find the current in the network. I is nothing but voltage applied V divided by the total resistance, which is R plus R. So it's V by 2R. Now voltage V1 is nothing but this current I into R. Therefore it's V by 2R into R. That's V by 2. Similarly, V2 will also become V by 2. Therefore, if a voltage V is applied to two equal resistances in series, the voltage will be divided equally among both the resistances. Example 2. Let's take some numerical values to the voltage and resistances and try to solve them. Suppose you have a 10 volt voltage source and you have a 8 ohm resistance and 12 ohm resistance, and we are asked to find the voltage across both the resistances, V1 and V2. The first thing we need to do is finding the current I in the network. I is nothing but the voltage applied 10 divided by the total resistance in series, that's 12 plus 8, which is nothing but 10 by 20 or half. Therefore V1 is nothing but the current I half into the resistance value 8, that is 4 volts, and V2 is current half into the resistance 12 ohms, that is 6 volts. One way to verify if the answer you got is correct or not, in the given circuit the total voltage applied 10 volt is nothing but V1 plus V2, and if you see V1 is 4 volt and V2 6 volt, so this also turns out to be 10 volt. If these two don't match, then you have done something wrong in the math. So let's take one more example, slightly complex one. So you have a 10 volt voltage source followed by a 5 ohm resistance and a 10 ohm resistance and one more 10 ohm resistance in parallel. And you are asked to find the voltage across all the three resistances. So since the voltages are same in parallel, across both the 10 ohm resistors it will be same voltage V2. So the first step is to find the current I. To find that, we'll be needing the total resistance R, and if you see, since the network is a little complex, you need to solve the resistive network to find the equivalent resistance R. And if you have two resistances in parallel, of value R1 and R2, it can be replaced by a single resistance R in the network, whose value is given by R1 into R2 by R1 plus R2. If you see properly, these two 10 ohm resistance are in parallel and in this form. Therefore they can replace by one resistance R, whose value is given by 10 into 10 divided by 10 plus 10, which is nothing but 5 ohms. Therefore the total voltage 10 volt is going to be divided between two resistances by 5 ohm, and I just replace the parallel combination of 10 ohm and 10 ohm with a 5 ohm resistance here. And we saw in our first example that if the voltage is applied to two resistances which are equal and in series, the voltage will be divided equally. So the 10 ohm applied will be divided as 5 volt here and 5 volt here. Therefore V1 is 5 volt and V2 is 5 volt. Let's see a last example. Example 4. We'll take a much more complex one here. There is a 10 volt voltage source, a 5 ohm resistance, a 10 ohm resistance, and you have one more 3 ohm resistance here, followed by a 7 ohm resistance here. So we are asked to find the voltage across all the resistances. So this will be, let's call this voltage V1, this to be V3, this to be V4, and voltage across the 10 ohm here to be V2. So we need to find the current I in the network first, and to find that you'll have to solve the resistor network. As you can see, these two resistances, the 3 ohm and the 7 ohm resistances, are in series. So the circuit can be simplified as 10 volt followed by a 5 ohm resistance followed by a 10 ohm. Since they are in series, they can be added and be represented by a single resistance whose value is sum of the resistances, 7 plus 3, that is 10 ohm. And this is same as our previous question, so I'll just write down the answers directly. So this will be 5 ohm, and since they are in parallel, this will also turn out to be 5 ohm. This will turn out to be 10 volt, and the voltage across the 5 ohm resistance will be 5 volt, and the voltage across these two nodes will be 5 volt. Therefore, in the previous circuit, the voltage here is 5 volt and the voltage here is 5 volt. So V1, which is the voltage across resistance R1, is 5 volt, and V2 is the voltage across the first 10 ohm resistance. This is also 5 volt. And now we need to find the resistance across the 3 ohm and the 7 ohm resistances. Since the 7 ohm and the 3 ohm resistance is in parallel with this 10 ohm resistance, the voltage V2 will be divided among the 3 ohm resistance and the 7 ohm resistance. So therefore V2 will be divided among V3 and V4. To solve for V3 and V4, just assume the circuit to be simplified as this. So you have a 3 ohm resistance here and 7 ohm resistance here, and you have the V2 voltage here, which is equal to 5 volt, and you need to find V3 and V4. As before, you need to find the current I here, which is nothing but V2 divided by the total resistance, that is 7 plus 3, so it's V2 by 10, and since V2 is 5, you'll get half. Therefore V3 is nothing but current half into the 3 ohm resistance, that is 1.5 volt, and V4 is nothing but the current half into the 7 ohm resistance, that is 3.5 volt, which both add up together to give 5 volt. So our calculation is correct, and we got all the voltages now: V3, V4, V2 and V1. If you understood all the 4 examples I solved, then you'll be able to solve any kind of voltage divider network. So that's all for this video. Thank you.